So this talk is called Batch Firmware Analysis. Basically, what I've been doing for the last 3 months or so is messing around with firmware. Quickly, who am I? Can you guys hear me? I have a bunch of people saying, pick up your mic. All right, is that better? Yeah. All right. So I go by Diagnosis on Twitter if you want to follow me after this. I do vulnerability research, reverse engineering, and exploit development. So all of that kind of works together, and it kind of goes together with what I'm going to be talking about. I wrote code for Saint Corporation. This is the only commercial slide you're going to see, and I thought it would be nice to throw it in because every single Friday, they let me work on messing around with hardware and firmware, and then they let me talk about it. I've been doing research for about 5 or 6 years, and I haven't been able to get on stage and talk about it because the companies think, oh, this is IP, this is important, we want to keep this secret. So instead, now I can actually talk about it. So it's Saint Corporation that's letting me do this. Okay, so this official looking slide, there won't be too many of these. I'm going to tell you what I've been working on, how I've been doing it, what I've found so far, and then we're going to get into a research drill down, which is really me just showing you about 6 or 7 zero-day on some routers. And then the conclusion, well, you'll see my conclusion. The research isn't done yet. I'm still doing tons and tons of reverse engineering. I downloaded about 200 gig worth of firmware, so I'm not even close to done yet. But I've done a lot of static analysis, and that's what this talk's going to be about. So I've done some static analysis. I found a whole bunch of backdoors, buffer overflows, etc. And so I'm going to show you those and how I'm planning on moving forward. All right. So my project thus far, the objectives have been to collect a large sample of vendor firmware images, take those firmware images and extract file systems out of those images, and I'll talk about that a little bit more later. Then I leverage that file system access to really take a look at what the device does. So I'm going to be looking at Squash FS file systems, and when you look at it, I extract it, and it's got your standard etc/www. These are little Linux devices. So I do some static analysis on that and find out, what's running, the binaries that are running, are they vulnerable to things like SQL injection, buffer overflows, etc. So I've, like I said, I've gathered 174 gig worth of firmware updates for TrendNet, D-Link, and Netgear. I harbor no grudge against these companies. I don't hate them at all. They just made it really, really easy for me to download their firmware, so that's why I focused on them. The unfortunate trend is that vendors are moving towards signing and encrypting their firmware rather than improving their code, but I'll talk more about that later. All right. So the methodology. First, grab a shit ton of firmware images, extract the file systems, perform diffs. So bin diff, does anyone know bin diff? Hands, bin diff? Yeah, cool. So bin diff is an IDA Pro plugin. IDA lets you reverse a binary into assembly. And bin diff will allow you to take the disassembly of 2 binaries, one pre and one post patch, and it will compare them, and it'll show you the code that's changed. So if you've got firmware updates for 5 or 6 different devices, you can do this bin diff against all these different versions and find out what they're addressing in between firmware images. And a lot of those things are vulnerabilities. So we'll look at that. I do a little bit of exploitation and exploit development using QEMU. Does anyone use QEMU here? Oh, awesome. Cool. So I use QEMU MIPSL static. and then I change root into the extracted squash FS file system. So basically what we can do here is we can take a CGI or a program that's supposed to be running on your router, and we can run it on a Linux system and attach a debugger. And that's really, really useful if you want to do something like fuzzing. If you want to send a whole bunch of data to that process and take a look at how it handles that input, you can do that on a Linux system in parallel and look at how it handles that malicious input. All right, so my key findings. There are vulnerabilities in third-party libraries and third-party services. So these routers that are running things like an HTTP server, they're running something called light HTTP. And they're running really, really, really old versions of it. So we'll look at that. They also run custom CGIs. So a CGI is just a binary that runs on the system. It's like an EXE for Linux. And I will reverse engineer those and take a look at the strings inside of those. UPnP and TR69, those are both protocols that routers have to deal with. And the amount of vulnerabilities in these two protocols is unbelievable. Jamie says I need to lift the mic. Thanks, Jamie. All right, so everything I've looked at so far has a vulnerability, like a remote code execution vulnerability. Everything is trash. All right, so I'll talk about the data collection really quickly. TrendNet has a website that if you go to downloads.trendnet.com, you can wget/r that shit. D-Link, they shut down their FTP server, dlink.com. ftp.dlink.com no longer exists. ftp.dlink.ca does. Oh, Canada. All right. And the other one, Netgear. Netgear was a little bit more contrived. They've got like a web interface where you can like pick your product. So I had to write some Selenium web scripts to automate a browser. And so I told the browser basically, hey browser, download all this shit. So I downloaded all of the firmware for TrendNet, Netgear, and D-Link. And that's what I'm going to be talking about today. The scope of the project is much bigger than that. I'm looking at NASs, refrigerators, TVs, all kinds of shit. But for this talk, we're just talking about D-Link, Netgear, and TrendNet. Okay, so TrendNet, they really suck at their naming conventions. So if you look, yeah, see? No, you can't see because this projector is. So I spent more time doing normalization of data than I did anything else, really. So I downloaded all of this firmware, and I have to have it in a naming convention that programmatically, when I consume it, I can understand where it came from. So basically, I needed to take the firmware and say the firmware is this vendor, this hardware version, this firmware version, right? Now, if you look at what I just showed, yeah, okay, so they're really shit at that. You've got a whole bunch of them that start with FW_, you've got one that starts with TEW, there's brackets, there's a bunch of bullshit. So I had to manually, or not so manually, I could like mass rename shit. But I had to go in and make sure that all of this made sense so that my later Python scripts, when I'm reverse engineering it and auto-extracting, it kind of all matched up. Oh, shit. Now what? All right, so these URLs are here because somebody's going to want to download the slides later and know what I said. So this is the URLs to download all of the firmware. I don't expect it to last too long, but there they are. So we've got 53 gig total worth of firmware for routers. This is a screenshot that I took after I organized all that garbage. Took a long time. Okay, and now we move on to bin walk. Show of hands, who's heard of bin walk? Awesome, cool. To you too. So bin walk is absolutely fantastic. We're going to be using bin walk to extract file systems. So there's something called a squash FS. It's a squash file system. It's a file that holds an entire Linux file system. That's what I focused on just for this presentation. There's all kinds of file systems. There's all kinds of ways that you can package a firmware. But for the purposes of this talk, I've just focused on squash FS. So the way to extract that, very simple, binwalk -e and then the binary file name, right? So what that'll do, it'll take the file name, it'll scan through, it'll look for some magic bytes that say a squash file system starts here, and then dump that out. It also does a whole bunch of other really cool things that I just wanted to mention really quickly because Craig is a really cool guy. Craig's the guy that wrote binwalk, that's not me. Mark said something about standing on the shoulders of giants. This is a great example of it. So yes, we can -e, we can extract the file system. -m does that, but recursive. So after it extracts a file system, it will also extract any ARJ, gzip, etc. Compressed files aside. What? What? Again, I swear it's legit. It's not, but it's a virtual machine, so. What do you want from me? Okay. Is anyone here from Microsoft? Honestly, it's legit. I bought a copy. It's just, you know. Okay, it also does binary diffing, but not in the way that bindiff for IDA will do binary diffing. It does do binary diffing, but it'll show you a hex dump. So you're stuck with that. It's really nice, though. You can identify a whole bunch of binaries that have changed between releases and then throw that in IDA Pro. So I'll show you how I went about doing that in a really ghetto way. Okay, so when you first run binwalk -e on a binary file, that's really blurry. No, garbage. I can't do anything. The top block here shows that it runs on a MIPS CPU. Second, it shows a bunch of stuff about the squash file system, that it's Little Indian, 3.0, the size, so it lets you know how many files are in there. And then it tells you that it's extracted it into squash FS root. Anyone that knows anything at all about Linux will recognize this. It's got a bin, etc, sbin. This looks pretty normal. So basically what we've done here is we've taken the firmware, we've extracted all of the files out, and we've got the little Linux system that the device is running available to us to analyze. So in this case, the first place that I looked was the etc directory. Again, people that are familiar with Linux will know that the rc.d directory and the RCS file is actually an initialization script. So that's where all of your files live that run when your device starts up. So I open that up because that's the first place I want to look. And from top to bottom, we see a bunch of stuff about mounting. So we take a RAM file system and we mount that into the etc directory. Not really all that interesting, but it does explain why etc is so empty. And then we see here cp-a mount /etc. So that means we've got a RAM file system. Take everything and copy it into the etc directory. We'll ignore all of this garbage, and then we'll come down here. There's two binaries that launch when this router starts up. One is System Manager, and the other one is TFTPD. Right? Okay, TFTPD is running. So, knowing that, strings, the ultimate elite hacker tool strings, I list all of the strings that are in System Manager, and I grep out etc. What I'm looking for here is files that I can steal with TFTP, because I assume since TFTPD is running, I can just download files. So the System Manager references a bunch of files, etc/rt.db, apdb, and apcdb. These are SQLite 3 database files that have the configuration information for your router. So that's all of the encryption keys and everything else. What else do we see here? We see rm-f etc www tgz and the untar, so the tar zxvf of etc www tgz. So this is the extraction of all of the web files, all of the HTML, all of the stuff that gets run on the router's web interface. And anything else interesting here? Well, there's tons of interesting things here, but that's what we're going to talk about for now. So my first ultimate amazing zero-day exploit was to TFTP into the router, switch to binary, and get rt.db. And like I said, that had all of the router's configuration information, and the device is owned. So that's garbage. So we'll pretend that that doesn't happen. What they did, they actually patched it. So I let them know, and they're like, oh, that's not good. We'll patch that, don't worry. So they patched it. They released a firmware. They sent me an email, and they're like, hey, we fixed it. Check it out. So I looked at it. Yep, OK, you removed that from the script. Perfect. Good job. So anyway, let's pretend that you couldn't do that, because you can't now. Well, you can, but I'll talk about that later. So let's pretend that you can't do that. So we're going to search the file system. So I ran find.name http. And what that did is it found a whole bunch of binaries in that directory. And one of them is light httpd. That's the web server that runs on the router. Okay? It also found, I did a search for CGIs as well, and it found my_CGI.cgi. And that's the main CGI that runs on this particular router. So we're going to want to take a really good look at that. Okay, so light httpd is an open source third-party application that we can actually just go to their website, and we see that there are a bunch of security fixes for this. Most recent, March 12th, 2014. So there's been a few months. I'm sure they've patched it, right? Oh, I love you guys. All right, so I did a strings, the ultimate hacker tool. So this is strings, and then the light HTTPD binary, and I grepped out server colon, right? Because inside of the binary, you know, when you connect to a web server and it's like server colon IIS 7.0. So it's the same deal. You connect to a light HTTPD server and it's light HTTP, 1.4.18. So you look here, there's a security fix in 1.4.35 and they're running 1.4.18. They haven't fixed that yet, so moving on. There's going to be a whole bunch of zero-day that I'm going to be talking about. You guys deal with it. So next up, I was like, okay, let's run my ultimate hacker tool strings against my CGI. And down at the bottom here with the red arrow is WC-L. That just counts the number of lines. So that's me showing you that there is 984 strings that were recognized. There's no way anyone could see that. This is all that's important. So after the 900 and some whatever strings scrolled by, this was at the very bottom. So there's two things here, right? Cameo_SW5 and Superman after each other. That kind of made me, huh? And then the next one is ping-c1%s, and then it pipes that output to a file %s. So that's probably not going to be good. All right, so it turns out cameo_SW5 is a backdoor, and the password's Superman. Yeah, thank you. Just to confirm this, after you look at firmware long enough, you see shit and you're like, oh, I know what you did there. But this is kind of just to confirm to you guys. So I opened it up in IDA Pro, and IDA's really cool in that if you see a string that's interesting, you open it up in IDA Pro, Shift F12 opens up the strings, you double click on the string, and then you right click and you go cross references. Show me everywhere in this program that this string is referenced. So that's what I did here. See? No, you can't see. So there's a function called admin login. And it checks to see if the user is cameo_SW5 and if the password is Superman. You don't need to understand assembly to know this is bad. All right, the next one, ping-c, %s, really? So here's the function. You want some feedback for next year? Okay, so this ping test function can be called unauthenticated, unfortunately. And down in the bottom right-hand corner, I'm sorry you can't see it, but right here, that says system. And this is ping, and this is %s, and then this is a sprintf. And basically what happens here is this function takes whatever you say and it concatenates it with this ping command. So of course you can pipe together commands using a semicolon. So if the user provides ping 10.0.1.1 semicolon run my shit, it runs your shit. And what's really cool about this vector is that the rest of the command really helps you out because it pipes it out to a text file. And then the CGI takes that text file and includes it in the response. So it's like you can't get any better. All right, so this is... What can I... All right, burp proxy, yeah. Burp proxy is what I use to kind of show this. So the IP address that I supplied is 192.168.10.2. %3, or %3b, I'm pretty sure is hex for semicolon. I mean, it must be. And then I ran BusyBox. So on the right-hand side, you can see in the HTTP response, it has the whole BusyBox output. Like, you didn't run me properly. Give me some parameters. So I give it some parameters. So here are the parameters. I'm like, why don't you run a telnet server on port 444 and link binsh? It says cool. So now I'm SSH'd into the box. What's really cool about this is that it doesn't ask for credentials. It just spawns a shell. So don't worry about that. You've got a shell. All right. So this is my CGI.cgi. So complex. How could I ever? So the first problem starts right here. The way a CGI works, let me just explain it really quick. I've got no idea how much time I have. I'm just blabbing. All right, cool. So the way a CGI works is you've got your web server, right? And then you've got a program. It's like an exe. It's like you just run it, right? So the way the web server does is it sets environment variables. Okay, so the HTTP server says set environment variable content length equals blah. Set environment variable blah, 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 blah. So you get to know what the client requested, and that's how the CGI and the web server talk back and forth. So the biggest problem with the router, and they haven't fixed it yet. Actually, if you haven't noticed yet, anything that I have in red text has been reported, but they haven't fixed it. And I've given them a ton of time, so don't feel bad for them. So anyway, the content links, when you make a web request, you know that HTTP header content links? So that gets passed to this program, and then it statically allocates a buffer based on that content length. And then it copies whatever you sent into that buffer. So there's a buffer overflow just by specifying content length. We'll pretend that that doesn't happen, because if we end it there, then that's really boring. So so let's just pretend that the content length isn't a buffer overflow that we can exploit pre-authentication and gain complete control over the router. Let's just pretend. Okay, so the next section here is a bunch of string compares, right? So the way it works is you make a request, and in the URL header, it's like request equals blah, question mark, blah equals blah. You guys know what a URL looks like. So this is just a bunch of string tests to see, hey, was this in the URL? You can't see that. So let me try and zoom in again. Here's one. No auth. Zoom in a little bit more. It says no auth, guys. Come on. That's funny. No auth. You supply the string no auth, and you don't need to authenticate. All right, so you supply the string no auth, and you don't need to authenticate. And then next, you can say no auth, but I want to do an admin login. And then that's this Cameo, blah, blah, blah. So no auth, and then you log in as admin with Cameo, and then after that, you launch the admin telnet interface. All of this, no authentication required. I'm not going to bother zooming in. You guys believe me, right? Okay, the slides are going to be available. You can like zoom in and be like, oh. Okay. All right, and so this really bothered me. I was going to say grinds my gears, but you've totally screwed that up. So this really bothers me. So I told them about this backdoor in their firmware, right? And I email them. I talk to them. Johnny and I, we go back and forth. And then he sends me a new firmware, and he's like, how's this? So I throw it in IDA. I'm like, cool, you guys did it. You removed the back door. I don't know why the back door was there in the first place, but cool, good job, guys. And then November 10th, they released a new firmware, and they reintroduced it. Not by mistake. Not by mistake. They actually encoded TFTPD this time as base 64. So they tried to hide it. They said, no longer does it happen when you request mycgi.cgi. That CGI listens. So if you request secmark524.cgi, and you supply the parameter ACCU MP524, and pass is kmark43. This goes on for a little bit. The code needs to be SMPWC. The hash needs to be /LJ9W, blah, blah, blah. And then commands, and then this, where the arrow is, that's a base 64 ASCII string TFTPD.
So they installed an obstacle course in front of your vulnerability.
Yes. And they lost my respect. Like, I actually talked to the people that are paying me to do the research. And I was like, this happened. What do we do from this point forward? And they're like, screw them. They're basically what they're doing is they're re-implementing a backdoor, but they're trying to make it harder to find. So Netgear will not be getting any vulnerability reports from me anymore. So anyway, they've reintroduced it on May 28th, 2014. 0 minutes, I'm done? Holy shit. All right, I'm gonna power through these slides really quick. So I did a find-name, binwalk. I extracted all of the binaries, and then I'm like, hey, let's do a find for all my CGI, right? We know this is vulnerable. How many routers is it running on? Okay, good, just 2. Wrong. Actually, it's 1, 2, 3, 4, 5, 6. And so it turns out they're also running that CGI in other ways. So there's another 2 routers that are vulnerable. There's a shadow file, and yeah, there's a whole bunch of built-in accounts. I didn't have time yet to throw these against OCL Hashcat, but I'm sure they're crackable. Here's a whole bunch of HTML files, and it turns out that if I put those in burp and do a www enumeration, the Netgear 6300, if you request the file congratulations2.htm, you get the WPA keys for all configured network devices. Yeah. Okay. So there's a whole bunch more stuff I want to do. I want to do cross-referencing vulnerabilities against all known platforms. I'm just going to leave. All of these slides are going to be available online. Please feel free to check them out. I'm going to be doing a bunch of MIPS exploits. What I really want to focus on is kernel exploitation. So they're walking at me. I want to focus on kernel exploitation because it's not just these web applications. These devices actually run wireless drivers, so you can connect to them and exploit them without actually having a WPA key. I also want to look at NAS's IP cameras, TVs, cars, refrigerators, and IP plugs. I've already done so. Here's some 0-day. So if you run a QNAP device, don't. This is a bunch of other stuff. I'm done.